In this video, we're going to start solving questions based on vector as our main topic. So our first question says, in the figure, 4 vectors A is equal to 15 newtons, B is equal to 8 newtons, C is equal to 10 newtons, and D is equal to 12 newtons. That makes angles with the horizontal of 0 degrees, 10 degrees, 100 degrees, and 160 degrees respectively. Their resultant vector is represented by R vector. Use the table to find the 1, we have the x component resultant, 2, we have y component resultant, 3, we have magnitude of the resultant, and 4, we have the direction of the resultant. Okay, just a clarification on how to resolve vectors. So like we said, all the vectors drawn on an x or y plane, or rather on a compass, you have to read their angles from positive x axis, meaning that any vector which is having an x component, that same component must be cut by the angle. What does it mean? Let me try to illustrate it as below. Okay, so like I said, all the vectors, if you try to graph them on an x or y plane, or maybe the so-called compass, you must read their angles from positive x axis. Even if they have given you the angles already, you have to make sure that you read every angle from positive x axis. So we have the first vector here, which is along the x axis towards east, but which is what A is equal to 15. They're saying it has 0 degrees. So I know that here, that's where you're starting from to count the angles to say this is my 0 degrees. And then you have to move to the second vector, which is what, 10 degrees. It has to be counted from, or it has to be read from positive x-axis going anti-clockwise like this until you touch that given vector. Same applies to this remaining one, the other one, which is vector C. This is vector C, and that one is vector D. You have also to read all these from positive x going anti-clockwise. Now, how do you draw the table of these vectors? You need to resolve every vector into x and y component, but you have to make sure that the component which is cut by the angle must carry cos. For instance, this one, since it is along the x axis, automatically it must only have x axis and it won't have y axis because it is along the x axis. Then this one, since it is neither in x nor in y, it must have y as well as the x. So the way I'm going to resolve this one, I'll resolve based on the x axis and also in the y axis. Now, how do you resolve? Remember, the axis which is cut by the angle has to carry cos. So we are saying x must be equal to what? You put the vector first, which is what? Which is 8 newtons. You say 8, then you say cos what? The angle, which is here. Then you say 10 degrees. For y again, you do likewise. So it will be the opposite. The identity to use in y, or rather the vector which is not cut by the angle, must carry sign, which is y is going to be equal to 8 sine 10 degrees. So every vector is going to be resolved in this manner. Even this vector, you're going to resolve it based on this angle. Same applies to that one also. You're going to resolve it based on that angle. But this one, it won't have the y-axis because it is along the x-axis already. This table is the one that I'm going to use to plug in every vector based on its axis. So we have the x component, we have the y component, there. I'm going to have vector A, I'll also have vector B, and vector C, finally D. Here I'll have the resultant both in x as well as in y. So here I have to write resultant in x, resultant in y. So basically this same table is the one which answers every question that we are from being asked. So if I'm to check, vector A is already along the x-axis, it won't have the y component. Automatically it must have 15, say cos 0. This one is going to have 15 sine 0. So since this is sign 0 automatically, I feel like it is going to give us 0. You come to B, which is having an angle of 15, sorry, an angle of 10. I'm going to say 8 cos 10 degrees. Let's say 8 sine 10 degrees. You go to B, I'm going to say 10 cos 100 degrees. You say 10 sine 100 degrees. And finally, you go to the other one, which is the last one, 12 cos 160 degrees, and also come to 12 sine 160 degrees. So the resultant in Y, you are going to punch this line 15 sine blah, even this one and that one on your calculator directly. You say equal to, and you'll be able to get the final answer on the resultant in X, in Y. Same applies to X axis. Alright, so if I'm to punch everything on the calculator, if I say 15 sine 0 plus 8 sine 10 plus, now we have 10 sine 100, then the last one, which is 12 sine 160. So whenever I say equal to, I'm getting the answer as 15. The answer is supposed to be 15.34. Okay, so I'll write this answer here saying 15.34. So remember, we are dealing with vectors. These are what we call vectors. Even this one must have the units of newtons. You come to this remaining one again. I'll do likewise by saying 15 cos 0 plus 8 cos 10 plus 10 cos 100 plus 12 cos 160. Definitely this one is giving us an angle of 9.87 whenever you try to do what, whenever you try to round off to 2 decimal places. So this is 9.87 newtons. Basically here I feel like we've answered some of the questions that we were asked. The X component resultant, which is this one. We also have the Y component resultant, which is that one. Now our main issue is to find the direction as well as the magnitude. Alright, so we have now the resultants both in Y as well as in X. R X, which is equal to 9.87 newtons, and R Y, which is equal to 10.34 newtons. Now what are we supposed to do for us to find the magnitude of the resultant as well as the direction? We know that for us to find the direction, we have to use the X or Y plane, or rather the so-called compass. So we know that if I'm to plot this, I'll follow the X as well as the Y. So since they all have positives, meaning that our angle, or rather direction, must lie from the from the first quadrant. It has to be something like this. That's where our theta is going to be, and this is the direction. You have to come to the resultant. How do you find the resultant? The magnitude of R has to be under the modulus, which is going to be equal to a root of R X square plus R Y square. Alright, so R, the resultant, must be equal to, you say, 9.87 square, 15.34 square, and that R as the resultant is going to be equal to what? So we can punch this on the calculator by saying 9.87 square plus 15.34 square. Okay, then equal to, we are getting the answer as 332.7325. So I'll write this here, 332.7325. When we say the root of the answer, what answer are we getting? we are getting the resultant of 18.24 newtons. This becomes the resultant. So this one, it has to be located at this given point as my 18.24 newtons to be my what? My resultant. Whenever I want to find the so-called direction now, I can find it from here by saying I have to use tan, because tan is the only one which helps us find the direction, because we have the resultant here, we also have the y-axis, I can also have the x-axis, which is rx, and then we have ry. What are we supposed to do to find the theta here? We can use tan, because we have the opposite and the adjacent. So this is going to be equal to ry, you say rx, down here you have theta. So theta is going to be equal to tan inverse ry, we are from finding as 15.34, and then down there we have 9.87. So the theta here has to be equal to, so whenever you try to punch this on the calculator, you say inverse of tan open bracket 15.34 divide this by 9.87, we're going to get 57.2 degrees. So you're having the direction of 57.2 degrees, and if you had to check it, is truly, because it lies in the first quadrant, and then this is going to be 57.2 degrees, and this is my resultant. So this one, in short, it qualifies to be our correct answers. Therefore the x component has to be equal to, you say 9.87, then y component has to be equal to 15.34, then resultant, which is going to be equal to 18.24. okay, and finally the direction, which is theta, has to be 57.2 degrees. Then everything qualifies to be in that case. Thank you.